How does the Earth move around the Sun? What is the heliocentric theory? What are its implications for us on Earth? In this video, I explain and discuss what we call heliocentrism. Although we now know the Earth and planets move around the Sun, this was not accepted until clues were amassed in the 17th century. It changed our worldview. Humans were not centrally placed in the universe, contrary to the prevailing philosophy and religion at the time. Similar arguments about man's place in the cosmos rumble on, from creationist dogma to rational aspects of cosmology. Early societies wanted the universe to revolve around them. In Antiquity, models of the cosmos placed the Earth at the center. Everything, all the heavenly bodies, they imagined, were affixed to crystal spheres that spun about the Earth. This caused the stars to be pinned upon them, or revealed through tiny holes within them, to circle the north and south celestial poles each night. The place of humans as the key to the universe's machinations was assured. There were clues that this comforting model was incorrect, and they have puzzled natural philosophers for generations. The idea that the heavens revolve around the Sun rather than the Earth, a heliocentric model, after the Greek word helios for the sun, was suggested by ancient Greek philosophers as early as 270 BC. Aristarchus of Samos conveyed such ideas in his writings. After calculating the relative sizes of the Earth and the Sun, Aristarchus realized that the Sun was much larger. It made much more sense for the smaller Earth to move, rather than the much larger Sunday. Ptolemy in the 2nd century used mathematics to predict the motions of stars and planets. He did so reasonably well, but there were obvious patterns that his equations could not match. The most common behavior is that planets occasionally reverse direction. Ptolemy, who imagined those before him that the planets turned on vast circular wheels in the sky, invented an explanation by adding small cogs to their orbits. He suggested that the planets rolled around smaller rings as they traveled along their main track, like a giant clockwork machine. These superimposed epicycles gave the appearance of the planet's occasional backward looping motions. This idea of epicycles stuck and was refined in later years. Philosophers were attracted to the idea that nature favored exact geometries. Nevertheless, as astronomers measured the planet's movements more accurately, their clockwork mathematical prescriptions increasingly began to explain them. As their data improved, the discrepancies only grew. Copernicus model. Heliocentric ideas were occasionally mooted over the centuries, but they were not taken up. The Earth-centered view prevailed by instinct, and alternative theories were nothing more than mind games. So it was not until the 16th century that the consequences of the sun-centered model were fully developed. In his 1543 book De Revolutionibus, Polish astronomer Nicholas Copernicus wrote down a mathematically detailed heliocentric model. This model explained the planets' backward motions as a projection of their movement around the Sun as viewed from a similarly circling Earth. By challenging the universal preeminence of humans, Copernicus's model had consequences. The established church and society favored Ptolemy's Earth-centered view. Copernicus was cautious and delayed the publication of his work until the year of his death. The posthumous argument was quietly put to one side after it was received. It fell to a more powerful figure to carry the baton. Galileo's conviction. Italian astronomer Galileo Galilei notoriously challenged the Roman Catholic Church by championing heliocentrism. His audacity was backed up by observations he made through the then newly developed telescope. Peering into the heavens with greater clarity than his predecessors, Galileo found evidence that the Earth was not central to all. Jupiter had moons orbiting it, and Venus had phases like the Moon. He published these discoveries in his 1610 book Sidereus Nuncius, or Starry Messenger. Confident in his sun-centered view, Galileo defended his argument in a letter to Grand Duchess Christina. Having claimed that it was the Earth's rotation that gave the appearance of the Sun moving across the sky, he found himself summoned to Rome. The Vatican conceded that his observations were true because Jesuit astronomers saw the same things through their telescopes. But the Church refused to accept Galileo's theory, stating that it was just a hypothesis and could not be taken literally, however appealing it was in its simplicity. In 1616 the Church prohibited Galileo from teaching heliocentrism and precluded that he hold or defend that contentious idea. Kepler's reason. Meanwhile, a German astronomer was also working on the mathematics of planetary motions. Johannes Kepler published his analysis of the path of Mars in the book Astronomia Nova, 1609, the same year that Galileo took up his telescope. Kepler found that an ellipse rather than a circle gave a better description of the red planet's orbit around the Sun. In freeing himself from perfectly symmetrical circles, he moved beyond Copernicus's model and improved the predictions for planetary motions. Although now considered a basic law of physics, Kepler's vision was advanced for his time and took a long time to be accepted. Galileo, 4:1, took no notice. Although restricted, Galileo remained certain that his sun-centered explanation was true. Asked by Pope Urban VIII to write a balanced account of both sides, in dialogue of the two world systems, Galileo upset the pontiff by expressing a bias for his view over that of the Church. The Vatican called him back to Rome and put him on trial in 1633 for breaking his ban. Galileo was placed under house arrest for the rest of his life, dying in 1642. A formal apology from the Vatican was only made 4 centuries later, in the run-up to the publication anniversary of his contentious book. Gradual acceptance. Evidence that the heliocentric view of the solar system was correct accumulated steadily over the centuries. Kepler's mechanics of orbits were found to hold and also influenced Newton's theory of gravity. As more planets were discovered, the fact that they orbited the Sun was obvious. Man's place at the center of things is no longer there. The condensed idea is that the Sun is in the center.